Assalamualaikum and good morning everyone. My name is Nur Akmalina binti Ahmad Kamal. My matrix number is 65043. Today I will be presenting about my final year project titled Spirulina as a supplementary feed for tilapia to enhance fish development, supervised by Dr. Lee Kui Soon. The goal of this project was to add spirulina that acts as a supplement to improve the commercial fish feed of farmed tilapia fish by including spirulina as a supplement and compare the results of the commercially fed tilapia with algae-fed tilapia. A total of 160 tilapia fingerlings were cultured. The fingerlings were grown on different experimental feeds with one replicate each. The experimental feeds were controlled feed with 0% spirulina, treatment 1 with 5% spirulina, treatment 2 with 10% spirulina, and treatment 3 with 15% spirulina. 160 tilapia fingerlings with the initial average weight of 4 grams were put into 8 different and circulated tanks with 20 fingerlings each, while the temperature and the water quality of each tank were maintained daily. The growth parameters that were observed are the weight and the length of the fish. The results were tabulated and the standard deviation and mean of the data were analyzed by using one-way ANOVA at 5% significance to detect the differences in the treatments. There was no significant difference among all the groups in terms of both weight and length. However, treatment 3 with 15% spirulina concentration showed the best growth. Treatment 3 has the highest body weight gain at 52.65 grams. Aquaculture refers to the reproduction, nurturing, cultivation of fish, shellfish, algae, and other species in a variety of aquatic ecosystems. It is a regulated mechanism analogous to agriculture, but with fish rather than plants or land animals, cited from Headland 2021. Due to the recent pandemic, capture fisheries output in some nations have been put to a standstill as a result of the decline in demand and accompanying price declines, which may have a beneficial impact on wildlife marine in short term. Malaysia's seafood export business experienced uncertainty as a result of the termination of fisheries, export deals, and preferential purchases from purchasing nations. Malaysia's aquaculture business has already begun to face the early effects of declining worldwide seafood demand, with seafood exports from Malaysia to Singapore falling by half in mid-February 2020, cited from Aruno, Lai, Timbuang, and Aravintan 2021. Thus, to avoid overfishing, which is environmentally taxing, aquaculture provides an alternative and safer way to farm fish, which is sustainable and could be a long-term solution. Specifically for this project, tilapia farming provides a cost-effective way of providing relatively cheap food for the market as consumer demands for tilapia grows. Although it is safer, it takes at least 9 months for a tilapia to be ready for harvest. Hence, by adding spirulina as a supplement to enhance fish growth, more fish can be produced and reduce wild-caught fishing activities, which will sustain the environment. This project has two objectives, which are: first, to use spirulina as a supplement to incorporate into the fish feed with 5%, 10%, and 15% concentration for 9 weeks. Second, to observe the physical appearance and changes of fish. Next, we move to literature review. According to Dauda et al. 2021, Malaysia's aquaculture sector is very diverse. The cultivation of seaweeds in Malaysia accounted for 51.5% of the total aquaculture industry in 2015. The Food and Agriculture Organization of the United Nations also revealed the total sea fish landed at 14,769 million tons in 2018, up from 14,651 billion tons in 2017 by 0.8%. In 2018, oil palm was the main contributor for GDP in farming, with 37.9% of the population led by other farming activities, 25.1% animals, 14.9%, fishing, forestry and logging, 6.9%, and rubber, 2.8%, cited from Mahidin 2019. According to Noel Gray, Caldwell, and Stead 2019, the number of caught fish populations decreased at an unprecedented pace, and many restoration measures were initiated by the authorities, and some strategies for overfishing were placed. Malaysia's aquaculture sector produced 427,022 tons of seafood valued at over 580 million pounds annually and was very lucrative. However, traditional fishing has placed massive pressure on wild stocks at almost 1.5 million tons a year and now has fallen at a disturbing pace. The decline of fishing resources in Malaysia could not be resolved by conventional methods of fisheries management, such as regulation of fishing effort, bent gears, the vessel size, and the engine power limit, cited from Xiao Nuridan, Hadil, and Richard 2020. Spirulina is a microscopic filamentous cyanobacterium named for the spiral or helical nature of its filament. Spirulina is the extracted substrate of Artospira platensis, a photosynthetic bacterium present in both fresh and salt water around the globe. This algae has been used as a protein source and supplement for humans with no major risk factors. It also has a high concentration of phenolic acid, tocopherol, and linoleic acid. Since spirulina does not have cell walls, it is readily digestible, cited from Nutraceuticals 2021. Spirulina has grown in popularity in the health food market and is progressively being used as protein and vitamin supplement in aquaculture diets. Because of the presence of certain chemicals, it may have the potential to be utilized as a natural feed additive in aquaculture to increase fish development, cited from Mosha 2019. Spirulina is a predominantly cultivated in a nutrient-rich liquid media where it is very land efficient and outyields many other traditional animal feed types in terms of protein, including wheat, corn, barley, and soybeans. Furthermore, spirulina can be actively cultured by enriching the growing media with desalinated wastewater and animal feces, cited from Holman and Malau Aduli 2012. Based on Ibrahimi et al. 2014, tilapia has the ability to elongate fatty acids such as ALA into omega-3, meaning that it could be possible to improve the omega-3 of fish by consuming ALA-rich foods such as spirulina. Tilapia can survive on plants and use those nutrients efficiently as stated by Ibrahimi et al. 2014, due to a digestive tract that when elongated is around 13 times their body length, allowing the time required to process nutrients. An aquaculture study by Jin et al. 2020 also reported that abalones fed with spirulina powder at 0.7% boosted body weight and shell size. Next, we move to materials and method. Figure 1 shows the nutrition facts of the spirulina powder used. The spirulina was obtained from Algae Living, manufactured by Algae Living Sdn Berhad from Batu Gajah Perak, Malaysia. It was delivered by the local post office. The spirulina was already in a dry powdered form that is suitable to be used in the diet. The picture above it is the experimental diet feed used for the project. The spirulina was added by replacing 5%, 10%, and 15% of the commercial feed. The mixture was homogenized manually by vigorously shaken in an airtight container. The commercial feed Takara Sakana was used as the control diet of the experiment and was obtained from a local market. The principal ingredients of the control diet are fish meal, wheat meal, yeast, germ meal, shrimp meal, vitamin and mineral supplements, and the granted analysis are as shown on Table 1. Figure 2 shows the source of tilapia fingerlings used for this project. Nile tilapia, also known as Oreochromis niloticus, was obtained from a small fish farmer where the initial weight and body size of the fish was an average of 1 inch and 4.35 grams respectively. The fish were grown for 2 weeks before starting the experiment to allow adjustment of water quality and acclimatization. As for the experimental design, the experiment was carried out in a 4-feet tank divided into 4 sections, using an aquarium divider and 4 cylindrical tanks as seen on the slides. The experiment was carried out at a residential housing area in Taman Nongchik Heights, Johor Bahru, Johor. 3/4 of the tank and circular tanks were filled with water that was previously treated with anti-chlorine. Before inserting the fish, the water was left overnight with the air pump running. The fish were put into the tanks with 20 fish each. 1 replicate was prepared for each treatment. The fish were fed daily at the designated time of 8 a.m. and 5 p.m. with a feeding amount of 5% of the fish body weight, which changes weekly accordingly. The fishes were weighed and the raw data obtained were tabulated every week before feeding. At the end of the experiment, after weighing each sample, the fish was filleted and observed and compared. The growth parameters observed were the body weight and the body length, the weight gain, which was calculated by subtracting the final weight with the initial weight, and the specific growth rate was calculated by the difference in final and initial weight divided by the number of days, which is 63 days multiplied by 100. All 160 fingerlings were measured, body length and body weight at the beginning. The average body weight and length were calculated and the data were collected every week. Both body weight and body length analysis were done by comparing the means using one-way ANOVA experimental design at 5% significant level. The mean was separated using 2-case tests to determine whether there were any significant difference among the treatments. All data were analyzed using statistical software to compare means. The data collected were analyzed using IBM SPSS Statistics 26. Next, we move to results and discussion. Table 2 shows the fish development at day 0, day 20, day 33, and day 63 respectively. From the graph in Figure 3 and Figure 4, it can be observed that 15% spirulina or treatment 3 showed the highest value in weight and length after 9 weeks, where the final length was 6.125 inches and final weight was 56.85 grams. Meanwhile, the control feed final length was 4.7 inches and final weight was 33.85 grams. Although the overall weight and length showed no significant difference as shown on Table 3 and Table 4, the experimental feed showed a positive or similar growth rate, with the controlled feed and 15% spirulina showed the highest result in weight and length of fish. These findings are found to be aligned with Nandisha et al. 2001, where up to 25% of spirulina replacement of fish meal can improve the development of fish. Furthermore, the specific growth rate increased with the increase in the spirulina diet. These results agreed with L. Ward et al. 2016, as it mentioned that the control diet had fewer values of body weight, weight gain, relative growth rate, and specific growth rate when compared to the experimental feed as observed on Table 5. In Table 5, the final weight at week 9 showed a significant difference through ANOVA analysis, where treatment 3 has the highest body weight gain, which is 52.65 grams, while the controlled feed diet showed the least body weight gain at 29.60 grams. The results obtained displayed that the survival rate of 15% spirulina was higher at 94% compared to the controlled feed, which is at 90%, is in agreement with the study conducted by S. Hasanain et al. 2018, where spirulina had an effect of recovery in fish growth and feed utilization, which shows that spirulina has potential in the treatment of fish toxicity. Islam et al. 2018 also reported that spirulina has a high protein content and showed no negative effects, which are ideal to use as a substitute for fish meal, and it does have an effect in increasing fish growth. Jana et al. 2014 also reported that the survival rate of fish with spirulina was higher than the survival rate of fish without spirulina. These findings conclude that the experimental diet with higher spirulina concentration improves the survivability of the tilapia fish. In addition, spirulina does not only affect the fish growth, it also affects the pigmentation of the fish. As seen on the fillet observation, 10% and 15% of spirulina supplement showed more reddish meat compared to feeds with lower and without spirulina supplement. A study by Temuri et al. 2013 reported that as the spirulina concentration increases, carotenoid concentration in the skin and fillet at 10% of spirulina concentration in the fillet and skin tissues also increases, as well as the growth performance of the rainbow trout. Jin et al. 2020 studied the use of spirulina on abalone growth and reported that shell coloration and shape have also been enhanced. These findings showed the advantages of spirulina as a supplementary feed for tilapia. There were no negative impacts on the fish. Instead, spirulina enhanced the fish growth in terms of length, weight, survivability, and coloration. Thus, this project has successfully achieved both of its objectives in using spirulina as a supplement to incorporate into the fish feed with 5%, 10%, and 15% concentration for 9 weeks, and observing the physical appearance and changes of fish. In conclusion, after 9 weeks of experimental feeding, the fingerlings fed with 15% spirulina had the highest body weight gain, which is 52.65 grams, and had the highest value in length, which is 6.125 inches. The tilapia fillet was also observed. 10% and 15% spirulina fed diets showed a more reddish skin and fillet compared to the ones fed with 5% and 0% spirulina, which showed a more yellowish skin fillet. In terms of survivability, 15% spirulina had the highest survival rate compared to the controlled diet. Hence, the 15% spirulina showed the best performance on fish development and growth among the treatment. However, the results of using 1 week ANOVA analysis showed there were no significant difference between the experimental feed and the control feed. These results showed potential in spirulina as a replacement for the fish meal to enhance the fish development, appearance, and survivability. Therefore, more research needs to be done to uncover the potential for the utilization of spirulina to replace fish meal. Thus, it can be considered for future use to reduce the harvesting of ocean fish and be incorporated in local aquaculture farms to produce more fish sustainably. That is all from me. Thank you very much.